In this final section, we're going to take a look at how we can prove that a limit does not exist analytically. And what we're going to have to do is we're going to have to be able to pick a path that xy falls upon and show that the limit is different upon two different paths that approach the value of the limit. Now, generally what I do is I try to limit it down to maybe 5 possible paths. All right, so usually, and most of the time, is xy is going towards 0, 0. All right, but as xy approaches 0, 0, there's a number of paths that we can take to be able to get to that path, or to get to that origin. So we could certainly take a linear path. In other words, y equals x. We could take the path along one of the axes. So in other words, y equals 0. Or we could even take it upon the x-axis or the y-axis, which is x equals 0. So we have this path that's possible. That's x equals 0. We could even do a quadratic path. All right, so if I were to y equals root x, or y equals x squared, excuse me. All right, so usually what I try to suggest to students is to start with some of the easier paths. Okay, and some of the easier paths are 0, y, x, 0, x, x, y, y, or even x square y or xy squared. Excuse me. And so what we're going to do is we're just going to show that the limit doesn't exist by approaching 0, 0 from different directions. Now you might remember that when we used our table of values, this was a limit that we showed did not exist. And so let's let C1, let's let that be the path 0, y. All right. And so what we would have is we would have the limit as xy approaches 0y. And what that means is that wherever we see an x, we're going to substitute 0. Wherever we see a y, we're going to substitute y. And that's going to be of the original function, which was x squared minus y squared divided by x squared plus y squared. And so if we substitute, that's going to be 0 minus y squared divided by 0 plus y squared. Or in other words, that's negative y squared over positive y squared, otherwise known as negative 1. So upon this path of 0y, the limit is negative 1. And we know that eventually that path is going to hit the origin 0, 0. Now how about a second path, C2? Let's let C2 be the path x, 0. And so the limit as xy approaches x, 0 of x squared minus y squared divided by x squared plus y squared. And again, what we're going to do is we're going to substitute x for x and 0 for y. That's going to become x squared minus 0 squared divided by x squared plus 0 squared, which becomes x squared over x squared, which is 1. And clearly, those two values are not the same, which means that on one path, from one side, we're approaching negative 1. From another side, we're approaching positive 1. Okay, so what we're going to say is that since the limit of xy approaches 0y of x squared minus y squared over x squared plus y squared does not equal the limit as xy approaches x, 0 of x squared minus y squared divided by x squared plus y squared, the limit does not exist. Right. Now that one was pretty easy because we could just guess some pretty easy paths. We could just use 0y and 0x, and that would be my recommendation to start. However, not all of them are that easy. All right, so a second example, we have limit as xy approaches 0, 0 of xy divided by x squared plus y squared. All right, so let's let C1 be the path of, let's just try 0, x. All right, so we're going to try it. It's trial and error. So that means the limit as xy approaches 0x of xy over x squared plus y squared. That's going to be equal to, by direct substitution, or sorry, we could use 0x or 0y. Let's just use 0y. Excuse me. So that's, it doesn't matter. They're both going to render the same outcome. That's going to be 0 times y divided by 0 squared plus y squared. And that just gives us 0 over y squared, which is 0. Now, let's say for some reason we use the same path as we did before. All right, so this is sneaky. Let's say we used x0. All right, so, and I'm going to erase this in a moment because this is not what we want. So if I take our limit xy, x squared plus y squared, that's going to be equal to x times 0 divided by x squared plus 0 squared, which is 0 over x squared, which is 0. And the whole purpose of this exercise was to show that the limit does not exist. Well, what we've actually done is we've shown that from two different paths, they approach the same value, but that does not mean the limit exists. That just means that we accidentally chose two paths that yield the same limit. All right, so let's try a different path. I'm going to try this path. Let's let C2 be the path x comma x. All right. So in other words, y equals x, which is that linear relationship. All right. So the limit xy approaches xx of xy divided by x squared plus y squared is now going to be equal to xx, x squared plus x squared, or that just becomes x squared over 2x squared, which is 1/2, which is clearly not the same thing. All right, so that's the goal. You have to use trial and error to be able to arrive at the solution, or at least the right path, to where the two limits are not equal. Okay, so we're going to say since the limit of xy approaches 0y of xy divided by x squared plus y squared is not equal to the limit xy approaches xx of xy over x squared plus y squared. We can say that the limit certainly does not exist. So our limit does not exist. All right. So what I'd suggest is maybe you pause the video and try to work this one on your own just to make sure that you're okay doing it, and then unpause it once you've gone through and gotten a solution. All right. I'm going to go ahead and work through it now. So I'm going to let C1 be the path. Let's just say 0 comma x. All right. It's always nice to try one of them to be 0. All right, because usually it works out really nicely. And so if I do that, the limit as xy approaches 0x of 2x squared y divided by x4 plus y squared is going to be equal to 2 times 0 squared times x. All right, so it doesn't matter. I should have made that y, but it doesn't matter. 0 to the 4th plus x squared, and clearly that's going to be 0 because the top just becomes 0. We get 0 over x squared, which is 0. All right, so we're looking for something other than 0. And I don't think that x comma 0 is going to give us the right path, because anytime you put 0 in the numerator, it's going to end up being 0. So let's try this path, and we have to try a specific path because we want to get down to a constant. Okay, we never want to have variables in our limits. The path that's going to work for us is going to be x comma x squared. And how do we know that? Well, I eventually want to get to some fourth degree polynomial. All right? And so the only way to do that is to maybe perhaps change y into x squared. If we do that, then we should end up with a fourth power. All right, so let's see what happens. Lim as xy approaches x comma x squared of 2x squared y divided by x4 plus y squared by direct substitution. That's going to be 2 times x squared divided by x to the fourth plus x squared squared. Or just by doing some basic algebra, that's going to be 2x to the fourth in the numerator divided by 2x to the fourth in the denominator, which is 1. Now clearly, the limit that we got from path 1 and the limit that we got from path 2 are not equivalent. All right, so one last time, we're going to say since the limit xy approaches 0x of 2x squared y divided by x4 plus y squared is not equal to the limit as xy approaches xx squared of the same expression, then we can say the limit does not exist. All right, so hopefully by going through these videos, you were able to learn a little bit about continuity, being able to approximate limits, and then as well being able to get exact values for limits analytically, and then finally being able to determine or to show analytically that a limit does not exist.